Alright, we've had some technical difficulties with this, so what I'm going to do is kind of just jump around the study guide to just kind of show you the main issues, and you should know a lot of the other ones. So I may do one or two Pythagorean problems, exponent problems, the ones that are difficult, but you could get through the rest of the study guide. So it won't give you every answer on this, but it will give you a handful. So we're going to go first to this one, the figure number 25. The figure is reflected over the x-axis, then reflected over the y-axis to form the image, where x, y, and z represent the sides of the image. Match the sides of the original figure with the image. So this is kind of interesting. It said it was reflected over the x-axis. So if we know this, we're going to take our marker, reflected over the x-axis. So it's like here. This is our x-axis, remember, right? Right here. So let me undo that. It would be like P, or R would be right here, S, and you could get super specific. Q would be right here, and then P would be like up here. And you're going to reflect that here. And it does help. I'm going to put P right here so you can kind of see. That would be what? This would be S, R, and Q. I will give you graph paper so you could do whatever you need to, and you'll have patty paper too, which will be great. Then it says it was reflected over the y-axis. So let me use a different color. And that's where this ended up. So it ended up flipping over here to this side. So if I was flipping that over the y-axis, this would actually be Q. This would help you guys. This is P, right? This is reflected, so this is S over here, and then on this side, this is, what is that, R, okay? So seeing that and labeling it should really help you in understanding what you're looking at. So it says segment PQ. That's what this means right here, and that's kind of confusing. We haven't gotten into the deep geometry, like content of understanding what these lines mean on top. So that means segment PQ, so right here, PQ, is also the same, match the sides to the new shape. So where is PQ over here? It's right here, right? So PQ would be the letter Y, okay? So let me go ahead and write that down. That would be the letter Y. And then let's go ahead and go back to this now. QR. Where's QR going to be? Right here. We can see it. It's right there. Letter is X. Look at the line. It's X right there. Okay. For which one is this one? So this problem is not difficult. It just looks weird on the benchmark. So you have to just take your time. It just looks a little bizarre. But it's looking at RS. RS is right here. Well, that's W. And then what is this? Q or SP? SP is right here, and we obviously see that's going to be Z. So don't let stuff that looks so strange to you make you think it's really challenging. This one wasn't that challenging. You just had to kind of map it out and see it in your brain. All right, number 26 should be super familiar. When we're looking at this, it says, are the figures similar or congruent, and what is the factor of dilation? Well, we're used to the word scale factor, but they're going to say just factor here. Now, the words similar and congruent, similar or congruent. Well, similar means that they're like a little brother and a big brother. Congruent means they're like identical brothers, like they're the same exact size and shape. And you're looking at these two shapes and you know they are not congruent. They are similar. So circle similar. And then scale factor. We did this a bunch. Remember, it's prime over original. And I messed up my prime sign there. But if I was looking at BC right here and BC here, I'm putting BC prime over BC. So BC prime over BC. And I look at the size of BC, and that's 2, or BC prime is 2, right here, right? And then I look at here from 8 to 16. Well, that's 8. So 2 over 8, which if I don't see that answer there, I could reduce this or turn it into a decimal. If I take 2 out of it, I'm going to get 1/4. And if I turn that to a decimal, it's like 1/4. 1/4 is 25 cents, 0.25, okay? So that's your answer for that one. On this one over here is this 27, looking to the right. I'm going to kind of keep this full page because it's been acting up on me a little bit. But it looks like this right here, and it's going to ask you, was this dilated? And if you look at this here, you can kind of tell, yeah, we're dilated from, it wants to know what was happening from ABC to XYZ. So this is going to be the first one, and XZ is the prime, and AC is the original. And we can look at that because we can compare the same sides. So XZ is going to be from -4 to +4, so that's going to be 8. And then AC just goes from -2 to +2. And if you don't see what I'm looking at here, I'm looking at the points here from here to here, and it's -2 to +2. This was 8. This is going to be 4. 8 over 4, we're going to break that down to +2, right? 4 into 8, 2 times. So you could say, yes, it was dilated by a scale factor of 2, then translated up. Oh, interesting. It's asking the different parts. Yes, it was translated 6 units up, then dilated by scale factor 2. Yes, it was dilated. I'm reading the answers here. Let's see. No, there is no sequence of transformations from A to B, C. Okay, so now it's asking about did it move up? And this is kind of tough. So I already know it was a scale factor of 2, but let's compare these 2 points here. And if this was the original and it went up to here, how many units did it go up? It went 1, 2, 3, 4, 5. I see 5. So maybe there's a problem with this one. We'll talk about this later, but at least you can find the scale factor. On the test, there's nothing this crazy looking. There is a moment where you may have to figure out what the dilation was, of course, and you can do that with the scale factor. All right, we're going to go kind of quick because I've had even more technical difficulties and I'm ready to throw this iPad in the trash, but we're going to figure it out. When you look at this problem, it says what series of transformations can be used. And when you compare these triangles, I really want you to compare the same points. It doesn't make sense to compare like this coordinate and you're going to move it over and then you're going to slide down to this one. That doesn't make sense, okay? If you wanted to compare this one, you would obviously compare it to the same one over here. So I'm going to take this coordinate and I'm going to compare it to this coordinate. And if I look at all of my answers, it says the right one can be obtained by translating it 8 units to right, 2 units down. This one says the right one can be obtained by 5 units to the right, 2 units down. This one says 5 units right, 7 units down. And this one says 8 units right, 7 units down. You notice that they're all translating. They're all translating, so we're sliding, right? And let's see what we actually are sliding. If we slide this way, that's 8 units to the right, all right? 8 units to the right, and then that's going to go down, what's that, 7 units down? If you look at it closely, look at your graph. So 8 units to the right and 7 units down. If you remember back in the day, not that you really need to know this for this one, but 8 units to the right and 7 units down. I hope you remember that stuff because that's exactly what happened. So your answer will be D. You have to read your answers. You have to read your answers and eliminate. That's the best way you're going to succeed on this test. Now number 22 has some challenge to it, but I would love for you to just think outside the box and really try. Use your patty paper if you need to, but what it's saying is give a sequence of 2 transformations that will show that shape A is congruent to shape B. It wants you to give them 2 transformations, and you know the transformations. There's reflections, there's translations, there's rotations, and there's also dilations. When I look at these 2 things, I know that they're not dilated because they're the same size. But I do look at this. If I was to translate this to the right, slide it, and then slide it up, it wouldn't look exactly the same, would it? But what if you can see it, what if I reflected it this way? Do you see how that flip would have happened? And then after the reflection, I slid it up. So I reflected it over, if you looked at it over the y-axis, right? I flipped it, and you could use your patty paper on this just to play around and see what would work. If I flipped it over here and then I slid it up, then I would get my answer. So that's what happened. I reflected it over the y-axis, and then I slid it up however many units. You'll have multiple choices on this, so read your answers. Okay, we're going to go now over to the number 23. And if we deal with number 23, it's asking about if it was rotated 90 degrees clockwise, what would the coordinates be? Well, real quick, we learned some rules. 90 degrees clockwise is y negative x. 180 degrees is negative x, negative y, just complete opposites, right? And then counterclockwise is negative y, x. So for this one, you can use patty paper too. You wouldn't need to use the coordinate rules, but I don't have patty paper and I can't really show that to you on an iPad like this, but I can just show you by knowing the coordinate. If it's -2, +4, all right, and we're going to go under a 90-degree rule. Well, -2, well, actually, my y goes here, right? So it would be 4. And my -2 goes here, but goes under the negative x, so it becomes 4, comma, +2. +2. And that's your answer on that one. Number 24 is seriously the easiest problem you're going to face. Number 24 just deals with the idea of looking at this triangle and understanding. Okay, let's just read it real quick. The figure is rotated 100 degrees about the origin. So they're trying to mess with you and saying you need to rotate this thing. Well, this thing's huge too, but if you rotated it, it would look interesting. What is the length of AB? The length of A, not AB, A prime, B prime. But if you look at AB and you rotated it, is the size of that AB going to change? So if I rotated this thing somewhere else, AB is not going to change in size at all. So all you have to do is just count the length of AB, and that's the length of A prime, B prime. Seriously. So they're just trying to see, can you even count the side and know that it's going to be the same exact side? It's congruent. It's the same. All right. So if you count this is going to be 8. This is 8 plus another 3, I believe, all the way to here. So 8 plus 3 is 11. 11 units is your answer. All right. Let's move on. Alright, I'm not going to go in that much detail on Pythagorean Theorem because we've done so much of it, but you need to find your L. In every triangle, you got to find the L. And you know the formula is leg squared plus leg squared equals hypo squared. And the only way to find your legs is to create your L and find that right angle if it's given to you as well. Now your legs are 6 squared plus x squared equals 7.5 squared. Now go ahead and solve that. You can do this. Go ahead and solve it. As you're solving this, you notice that this 36 has to subtract. Your leg has to subtract. Unless you have both the legs here, then you add them, but you must subtract it, okay? Then you're going to square root both sides, go off the wall, square root both sides, x equals 4.5. Alright, 4.5. Alright, next problem. You're going to use your graph paper, and I've given you graph paper, or I'm going to for the test, but if you draw a graph, we did this one in class, if you remember correctly, and I'm going to plot my coordinates. So over 10, down 3, there's a coordinate, alright, and then negative 2, up 6. It doesn't have to be perfect, but we want to know what is the distance between these two coordinates. And if we do look at this, you can tell this is my hypo, and I have to create legs from this, okay? So I'm going to create the legs as I go down this way, here, and here. You got to create it on the graph paper. And then you just got to count it out. And once you count them out, we went up 6 and then down 3, so this is going to be 9 on this leg, and this one is over 10 to here, but you're just going to count it 12. So 2 is on this side, all right? Make sure I did that right. Negative 2 over 10. Oops, hold up. This is not 9. Is it? We went up 6. Oh, yeah. We went up 6 and down 3. If we look at this closely. Yeah. Yep. So this is actually 9 and 12. So my triangle looks like this. 9, 12, and x. Go ahead and solve that for me. You guys are going to go 9 squared plus 12 squared equals x squared. Go for it. If you actually did do the work, 9 squared is 81. 81 plus 144 is 225. You get 225 equals x squared. Off the wall there. It's a perfect square. You get 15. Alright, so that would be 15 for that one. You must graph and create legs for this one. Do not mess this one up. It's such light work. Let's go. Alright, the only 3 problems I want to talk about on the first page is numbers 8, 9, and 10. Actually, I did talk about before the last one, but here we go. 8, 9, and 10 for exponent rules and square roots. So when we're doing this one, it says choose all the expressions, all. So we can do this one. We know we're supposed to add in here. So we're going to add negative 8 and positive 3. You're going to add those exponents inside, and you're going to get negative 5 on the inside. Do that inside first, and then you still have that 3 on the outside. You should know that 3 on the outside has to be multiplied, okay? So 4 to the negative 15th. And you're like, okay, cool, I'm done, we're good. But I want you to make sure you read the problem. When it says choose all, you better find if there's any other one that would equal 4 to the negative 15th. Well, obviously A is not. And if you look at B, there's no way that negative 5 and 6 are going to work. But look at D. When you add negative 24 and 9, you get negative 15. And also, what else could equal negative 15? What if I did this right here? Isn't that also negative 15? Because it gets flipped. Remember, your negatives can't stay negative for a final answer, but this one it is. If it's in the multiple choice, go for it. Now, number 9 is kind of a trip. We did this on the Rally Coach yesterday. You don't get a calculator for these ones. So you have to estimate, and it says which one is the closest. It's not going to be precise, but it's going to be closest. And if I look at this problem, I'm going to take a look at this. I'm going to actually make my pen a little smaller when I do this one, because I'm going to do 36 and 49 when I do this one. And I look at 45, and I know it's closer to 49, so I'm thinking like 6.6 or 6.7, something like that. Okay, probably 6.7 even if I did it in a calculator. But regardless, we're just kind of estimating, we're approximating. And then this one, 37, I know it's really close to 36, not 49. So I'm going to say like 6.1 for this one. And what do I do with those two numbers? It's telling me to add, so I'm going to add them. And I get 12.7. Well, remember, what's the problem asking? You got to always know, what is the problem asking? It says which one is the closest. So I look at this and I go, oh, it's 13. 12.7 has got to be closest to 13. Not B, 15, but C, 13. Now take a look at number 10. Number 10, to get rid of, and really what's asking is, what number to the third power equals 125? What number to the third power, right? So what number times itself? Isn't it 5 times 5 times 5? So y equals 5. And that's what it looks like. But it also could look like this. When you want to go and get rid of this 3, you got to go off the wall, but you got to put a 3 in front of it. It's kind of confusing. So another answer could look like this. All right? So these two are qualified answers. These two. Put that in your brain, study it. It looks confusing, but study this. Look what I'm telling you. This 3 on the outside tells you what number to the third power. All right. When we used to do off the wall, there's nothing there. That means it's actually, we'll talk later, but that 2 would be invisible, the squared. But this is right here. 3 is there. All right. All right, let's get down to business here. If I was looking at this problem, how many times larger is 1 times 10 to the 13th than 5 times 10 to the 4th? You could look at I really want you to look at your answers, but if you were to write this out, really, whenever you see something like this, it's a division problem. It's a division problem, and it looks kind of confusing, but it is going to be a division problem. Oop, and this is 13. So when you divide, you're going to deal with this part first, and then you're going to battle these. So when I look at the battle already, I know it's going to be 10 to the 13 and 4. The difference there is going to be 7. All right? And then if I did this part here, where in my calculator, I get 0.2. Okay? Now, is this problem, this is very important that you see this, is this problem in proper scientific notation? Like if I wrote this out 0.2, and I go 7 times, I go 1, 2, 3, 4, 5, 6, 7, and I write it out, and I put all these zeros, and then that's my answer. It's actually going to be, what, 2 million? Yeah, 2 million. How would I write 2 million, though, properly? The decimal's not supposed to go here. It's supposed to go over here. So let's go ahead and write this properly. If I put the decimal here, 2.0, you don't even have to put, well, you can just put 2 times 10 to the, if my decimal's here, it's 1, 2, 3, 4, 5, 6. 2 times 10 to the 6th. And that would be your answer. Kind of a trip. It's kind of interesting. These ones are going to be a challenge, but whenever you see something that says how many times larger, you're going to divide. How many times larger, you're going to divide. Okay? And I'll go over that a little bit in the warm-up on Monday. All right, for this guy, you're just going to go ahead and divide those. Divide 63 into over 7, and you should know that actually 7 into 63, 9 times. I'm going to use a different color. 9 times. Times 10 to the, do this battle. Who wins the battle? The top by 6, and then you're done with that. Alright, if I'm giving pointers on this, I want to make sure you understand these negatives can't stay there. We did this a bunch. You guys should be okay, but do your work. Don't just copy me. But know that the negative 2 has to pop up, so 8 to the 7th on top. The negative has to go down low, so 7 to the 7th on bottom. And then this 3, 1 goes up top, and the 3, 5 goes on the bottom. We flip those, right? And then we battle, and the bottom wins by 4. That's a 4 there. It's kind of hard to look at. Number 12 talks about there's this many insects and this many of insect B. How many times more of insect A are there than insect B? Again, how many times larger or how many more, you're going to divide. You can do that later, but when you look at this, it's not too tough. I'm not going to do this one for you guys. This one, just write them out in normal notation if you can, and just add them. You see that addition sign? We did that with the rally coach. And then this guy down here, you're just going to multiply. So I will do this one. You're going to multiply those two numbers, 8.6 times 8. So use your calculator, 8.6 times 8, or you can just, and I'm going to get 68.8, okay? And then what am I going to do with my exponents, 10 14th, 10 negative 13? If I was doing this problem on a normal like exponent kind of rule, don't I multiply? And don't I add, when they're multiplied, and I get times 10 to the 14 minus 13 is 1. This is the confusing part. My decimal is not in proper notation, right? This is not good. My decimal should be right here. It should be right after the 6. So if I was to actually do this properly, it would be 6.88 times 10 to the, well, if I want it to be 68, it's going to be actually, when you move this over, it's going to be 10 squared. When you move this to the left, you're going to add 1 to your exponent. And it looks kind of confusing, but 6.88, actually, hold up. No, we're good. So 6.88 times 10 to the second, I got a little confused there, times 10 to the second. I'm moving on this side, all right? If you were to do this problem, and you actually wrote it out in normal notation now, you go over twice, you're going to have 688. 688. So, where do you see that number? Which one's closest? And it's going to be 700. It's a confusing one. We're going to go over this one tomorrow for sure before we start. Alrighty. I'm going to go ahead and tell you this one is going to be a multiplication problem. You're going to multiply 500 times 5.02. And you're going to get 2,510 times 10 to the 22. Alright? Now, when you look at this problem, and you did the multiplication, you got to realize your decimal's over here. You're going to move it over to the left 3 times. 1, 2, 3. And like I said, it's kind of confusing, but when you move it to the left like that, you're going to add it. So it's going to be times 10 to the 25th, and it's going to be D. That's a tough one. There's only one problem that's super tough like that, and I'm kind of annoyed that it's even on the benchmark, but we're going to try to get through it. Now, I'm going to erase some of this stuff so I can get through to you guys on this last part. This last part, you guys should be fine on, the triangles, understanding what's happening here. When you see these triangles like here, this parallel lines and then your transversal, right? It says if this length here, what does it say? If measure of angle 7 is 31 degrees, what is the measure of angle 3? Now just even look at the size of the angles. This is a little angle, right? 31 degrees. This is a big angle. Look at the size of that one. Let me draw it a little better. This is bigger than 90. That's an obtuse angle. And if you were to slide it down, isn't it the same size as this angle here? And if you're looking at this, my windshield wiper, it's all equals 180. So all you have to do for this one is subtract it from 180, and you're going to get 149 degrees. That's a tough one. We're going to get through it. And then number 19 talks about isosceles triangles. That means these two are the same. So if 52 degrees is on top, I subtract it from 81, and I'm going to get 180, and I get 100, and I believe, what's that going to be? 28, not 38, 28. So I have 128 degrees to divvy up to these two angles. 128 degrees. We'll just divide that by 2. You'll have a calculator. I get 64 degrees for those, okay? The last one, you're just going to multiply those by a half, which means you just cut it in half. So -5 and -6 would be your new coordinates for the bottom one. All right, guys, I hope everything works out. We're going to ask questions on Monday.